In this lecture, I want to just teach you how to draw streamlines. I'm going to use particular MATLAB, but you're welcome to use any other software you want to use. We did this example in class, and where the velocity, we had the velocity vector, and the velocity vector was given by x squared minus y squared uh, I minus 2 times xyj. Okay, this is the velocity vector. And we showed in class, this is the equation that we got. So what you're basically going to do with the equation is, you're going to set your equation equal to 0. So you say this minus this, okay? And typically when you do your integration, you're finding streamlines end up being a constant, right? So you leave the constant on this side. Now you said that this is going to be your new function. Okay, that new function is the one that we plot. I'm going to teach you how I do this in MATLAB, and then I have saved a copy of the file. So here in MATLAB, the file name is called Streamline Example. In this example, the first couple of lines, this clears all to make sure you're starting from scratch, clears the command window. So all this is cleared. CLA is to clear the graph. And this is just output information. This is for output information. Here you're more than welcome to change your name and your the course ID and the section number. And then when you're doing all this, this is the time it was completed. Okay, so this right here represents a set of vectors from where to where I want to plot. Okay, so I want to plot all the values of x between minus 15 to 15 and minus 15 to 15. Okay, so basically these couple of lines, this is what they're doing. They're saying take a space, okay, take a space in x, a space in y, and put an imaginary box right there, somewhere there, here at minus 15 to 15, and this is 15 and minus 15. So this is what he's trying to do. He's saying all the put bunch of points. Now what I want to extract from here is all the points that are here. I want a mesh that gives me all the possible combinations of all the possible points I can have in this region. So that's what the next, this is what the mesh is doing, is giving all the combination of x and y's. So now I call it a z, okay? So what you want to do now is you want to, you have to put a dot anytime you have it's a vector or a matrix in MATLAB. So you can see my function, the function that we had, we go back to the function. The function was right there. Okay, so the function was x squared. So I have a dot before the upper 2, and then I multiply, before multiplication is a dot again, and capital Y. You have to use capital Y, so this is the combination of x and y. Minus y cubed over 3, okay, divided by 3. So I don't put my constant. This is already my constant. So in MATLAB, if I did this, you can use, this is just to give a name to the plot. And I am going to change that name to Streamline Example. You can call it anything you want to. This ensures that this is the plot that you're doing. Okay, I want to have 20 contour plots. And I want to plot x, y in the xy plane. And this is my function that I'm actually plotting. Okay, and then this is just gives you the axis, so you can change, you can control what region you want to plot or not. And then this is the output of the file. So to run in MATLAB, you just press, so the only thing you'll have to change in this code, you change this, you can keep this the same, and you can change the function. Then you can, this right here, run, you press enter, and that runs it, and that gives you the plot. Okay, these are the contours of this function. And if you remember when we did the example in class, I showed you that the contour looks like this, right? You wonder, where did that come from? Well, it comes from a streamline that looks like this. Now the question is, I want to know, in what direction does this flows go? Do they go in this direction, or they go in the opposite direction? Well, in order to do this, arbitrarily just choose a point. The easiest point to choose here is, let's say, 0, 0, 10, okay, 0, 10. So I can go to my function, I go to my vector, my velocity vector, that's given by this guy right here. And what I'm going to do is, I'm going to say, I'm going to take a point, okay? So I chose the point 0, and I say what happens is v is equal to 0 when this is 0, okay? So this is minus 100. So I'm evaluating this at x, y coordinates 0 and 10 positive, okay? So it's this location right here. And this is 0. So say it gives you minus, right? So it's telling you, and you can see that I told you this goes in this direction, but then you can come here and say, oh, wait, so it's going in the minus I. It's going in this direction. So you can say that all the flows here go in this direction, okay? Now, if you want to find out what happens here, let's say, then you can just choose a point, let's say 10, 10, okay? Is just an easy point that you want to choose. Or you can just choose an easy point and just go maybe a point, this is minus 10, minus 1. You can choose minus 10, minus 10. So how about I choose a coordinate minus 10, comma, minus 10. And that would give you 100 minus 100. That gives you 0. Minus minus become positive. So this gives you 200J. So what this is saying is actually going downwards at that particular point, minus 10, 10. This is going downwards. So he's saying this is going in this direction. And you can see that I told you, just give me a minute. Yeah, this is plus. If you realize I made a small mistake, it was plus 10. So then this becomes plus. It goes in the opposite direction, okay? So it goes up. Again, this is minus plus, but I'm choosing this point. This is plus, this is minus. So you can see it goes in this direction. So all the flows here will be going in this direction. So if you wanted to find out what happens in this direction, let's say, then you can choose minus 10 and minus 10, okay? So if I was to choose minus 10 to minus 10, I will let you show that to yourself. This gives you minus 200J. So it's minus 100, so it goes in this direction, goes downward. So it's saying all this flow is going in this direction. So it's going opposite directions. If you wanted a location here, let's say, then you can choose X, Y in the 0, minus 10 direction, okay? And if you did that, you will show that you can show that V is equal to minus 100I. So it's saying this is going in this direction, okay? And it kind of makes sense because they have to be in consistency. That's how you actually, and you can keep on doing this. You can do this for yourself. You can show this goes in this direction. This is going to go in this direction. So you just find those locations, and that's how you plot them. So this is one way to plot, and I will make the code available. and you're free to use.